it once again.
Hello, today I want to talk about how a submarine can sink and rise. Most submarines have two types of tanks, the main ballast tank and the trim tanks. The main ballast tank is used to move the ship up and down. The trim tanks are used to balance the ship. Let's take a look at the main ballast tank first. If the tank is filled with air, the submarine is lighter than the surrounding water, and it will float on the surface. If the tank is filled with water, the submarine is heavier than the surrounding water, and it will sink. The main ballast tank has holes on the bottom and a valve on the top. As long as the valve is closed, the air bubble is trapped in the tank. If you open the valve, the water pressure is forcing the air out of the tank. As there is more and more water getting into the tank, the ship is getting heavier and it's starting to sink. If you want the submarine to rise again, you need to replace the water with air again. To achieve that, compressed air is pumped into the tank. The air pressure is pushing the water out of the tank, and the ship is getting lighter again. As the compressed air is a limited resource, you want to waste as little as possible of it. Therefore, the last bits of water are normally pressed out by normal air or by using the fumes of the diesel engine. The second type of tanks are the trim tanks. Normally, the trim tanks are positioned at the front and at the back of the submarine. As I mentioned earlier, the trim tanks are used to balance the submarine. Let's assume the front part of the submarine is heavier than its back. In that case, water from the front tank can be pumped to the tank in the back until the ship is in balance again. When the submarine is submerged, it can also use its diving planes to move up and down.
cargo ship is designed to carry different weight and volume of cargo under the safe limit, to avoid grounding and sinking of the vessel. The load line is a special marking, positioned amidship, which depicts the draft of the vessel, and the maximum permitted limit in distinct types of waters to which the ship can be loaded. The fundamental purpose of a load line is to allot a maximum legal limit, up to which a ship can carry the designated cargo. The buoyancy and immersion of the vessel largely depend on the type of water and its density. It is not practical to define a standard freeboard limit for the ship at all times. Hence, different geographical zones will have different prescribed load line. Deckline is a horizontal line, measuring 300 mm by 25 mm. It passes through the upper surface of the freeboard. Load line disc is 300 mm diameter and 25 mm thick round-shaped disc. It is intersected by a horizontal line. The upper edge of the horizontal line marks the summer salt water line, also known as plimsoll line. Load lines are horizontal lines, extending forward and aft from a vertical line, placed at a distance of 540 mm from the center of the disc. They measure 230 mm by 23 mm. The upper surfaces of the load lines indicate the maximum depths to which the ships may be submerged in different seasons and circumstances. Summer load line is the basic freeboard line, at the same level as the plimsoll line. Other load lines are marked based on this summer freeboard line. Tropical load line is 1/48 of summer draft, marked above the summer load line. Winter load line is 1/48 of summer draft, marked below the summer load line. Winter North Atlantic load line is marked 50 mm below the winter load line. It applies to voyages in the North Atlantic, above 36 degrees of latitude, during winter months. Freshwater load line is the summer freshwater line. The distance between summer and freshwater line is the freshwater allowance. Tropical freshwater load line is the freshwater line in tropical. It is marked above the tropical line, at an amount equal to freshwater allowance. It is important for any ship to have a safe draft, for safety and to avoid grounding. The draft can be measured vertically, between the keel and the waterline of the ship. If the ship is loaded with more cargo, the draft will increase. Load line also helps in determining the freeboard of the ship, which is the distance between the shear and the waterline. Again, if the draft increases, which means more volume of the cargo has been loaded, leading to a decrease in the freeboard. If freeboard is reduced more than the required limit, it may sink the vessel.
Alright, well Ayla, we're going to do a really cool science demonstration here today. And it's going to represent kind of what happens with warmer air and cooler air. And we've talked about, temperature, air pressure, things like that in class. And what do we know that warmer air likes to do?
It likes to go up.
Yeah, it rises up, right? And the cooler air will kind of sink to the bottom. And that's the principle that's used in hot air balloons. You've, I'm sure, seen the hot air balloons out, floating around before, right?
Yes.
So we're actually going to make a hot air balloon. And to do that, the first thing we need is a bag. And I've got just a thin trash bag here. You want something pretty thin and pretty light. So we're going to use this trash bag to make a hot air balloon. But we also need to kind of make a little support frame for it. And we're going to use straws for that. I'm going to give you 3 of those. And have you ever taken straws and kind of stuck them, folded the ends and stuck them into each other before?
Yeah.
Okay, just go ahead and kind of stick those together for me. Get those, we'll kind of put them all together and make us a square frame. And this will go on the bottom of our balloon. But if you want to hold on to that, what we need to do now, we need to actually tape this into the bottom of our bag.
Okay.
So we'll get our tape and we'll get our bag. You want to hold the bag open. Kind of a two-person job here. But if you want to trade there, and if you'll hold the bag open, we're just going to kind of tape this inside here. And that way we'll have a nice opening at the bottom to let our hot air into. Because basically the way a hot air balloon works, it fills a big balloon, if you will, or basically a big piece of cloth with warm air. And that warm air, because it's so much lighter than the cooler air around it, is going to want to rise up. And because they have so much air, they can actually lift that basket, they can lift the people that are in it, and it can carry a lot of weight. Now ours is obviously a little bit smaller, so it can carry the weight of itself, but that's about all. But we're going to just kind of get some warm air in this, and we'll see just how far we can make it float up. We're going to see if we can get it all the way up to the gym ceiling. That's going to be kind of our goal. All right, let's flip that around here, and I'll take the other side. All right, so now we've got a trash bag. We've got a little frame around it here, and this is going to fill up with hot air. Hopefully, if everything works right, we'll fill it up with some hot air. And in order to do that, we're going to need a source of heat. And what we're going to use, I've got, if you want to hold our balloon for us there for a minute, but in our little pan here, we've got some solid alcohol. And this is what they put when you go to like the buffet line. They've got those little fires burning underneath. It's basically a solid form of ethanol. So it's not going to run everywhere. It's going to stay where we put it, but it's going to burn. It's going to generate the heat that will lift our balloon. So we're going to set this down and light it. Now the way we're going to do this, I'm just going to have you hold the top of the balloon because it's going to take it a few seconds to fill up. And if you just want to hold it there, and I'll kind of lower the bottom down closer to the flame when we get it lit. All right, and you can just hold it there. It'll fill up on its own. All right, so we get it lit here, and let's just lower it down just a little bit, and this fire is going to start warming our air inside here. I might need to. Oh yes, definitely. You know, it makes it significantly warmer inside the bag, and then you can actually let it go now, and it's probably going to want to stay up on its own. So we're going to hold it just a little bit longer, and we'll go ahead. We'll give it a countdown from 5, and we'll let it go. So 5, 4, 3, 2, 1. Hot air balloon. All right, it kind of flipped over, and the warm air got out there. Let's give it one more try here. Let's see if we can get it to stay upright. Because sometimes they do like to flip around. All right, we'll hold it over, warm it up again. You can go ahead and let go of the top. Let's try it again. 3, 2, 1. Here we go. All right, flipping again, but you still see that idea, the concept there. And if you put your hand in there, just feel how much warmer the air inside the balloon is. Yeah, it's pretty hot air, even though, you know, a lot of that actually escaped out. But that's that concept of lighter air being able to rise up because it's so much less dense than the cool air. And that's what happens to work with hot air balloon. That's what happens to the air in our atmosphere as well. We get those, you know, we talk about those convection currents in the atmosphere that move warm air around the globe, move our weather patterns. And, you know, obviously, you know, as the sun shines down on the earth, it heats the air close to the air, it heats the ground, which warms the air. And that rises up and pushes the cooler air down, and we get these currents constantly circulating, kind of like happening there with our hot air